Yeah, it does appear to be spinning, but I do want to remind everyone that everything after clearing the tower was icing on the cake.
As many of the people who listen to the media about spaceflight might know, the largest, most powerful rocket just launched on the 20th of April 2023. And it was incredibly successful, just not in the way some of my viewers might be expecting. When at full throttle, the vehicle had an approximate thrust of 76 million newtons. And where do you get all that thrust from? Well, you need a lot of really efficient, state-of-the-art engines, 33 of them in total. Such an incomprehensive amount of thrust actually ended up destroying the launch pad. Just look at the right side of the rocket. So much concrete debris is spewing out of the ground. Taking a look at this shot at the sea, you can actually see a lot of shrapnel raining down into the Gulf of Mexico. Still don't believe me? Check out these pictures from Lab Padre and Paul Breed. It literally ended up digging a cave into the ground, and this is going to take a lot of time to repair. Since Boca Chica, Texas, the launch site of this incredible rocket, is at the water table, which is the fancy word for sea level, it's going to take a lot of time to dig through all that nasty swamp water that's leaking down into the hole. So why did the SLS, which had similar thrust to Starship, not completely obliterate its launch pad? It's because Starship is supposed to take off from the Moon and Mars, where advanced rocket launch pads cannot be built. Many modern launch pads use a flame diverter, which, as the name suggests, diverts the flames and other nasty things that the rocket is spewing out into the outside environment. So SpaceX practiced not to put a flame diverter under the launch pad, and this was a massive mistake. This panorama shot from Starbase Surfer shows that the fuel tanks built to fuel the Starship rockets have been entirely damaged, and most of them will have to be replaced. Elon Musk, founder of SpaceX, claims that another Starship would be able to launch in 6 to 8 weeks. Honestly, I would be really surprised if we had another launch in 6 to 8 months, due to the monumental repair work that will have to be done to the launch pad. For the next launch, he plans to place a massive water-cooled steel plate to divert the blast. Okay, that's great to know, but what about the Starship itself? What happened to it? I will be reviewing everything in the launch, from the countdown to the explosion, so here we go. Exactly at liftoff, the rocket ended up tearing a giant hole through the ground, as I mentioned earlier, and then it started to rise. Take note that the vibrations from the launch were so incredibly strong that it ended up ripping some heat shield tiles off the Starship, which are necessary for its re-entry back to Earth to do its landing maneuver. Without these heat shield tiles, it could severely damage the Starship, or worse, completely obliterate it from the immense heat, like the Space Shuttle Columbia disaster in 2003, tragically ending the lives of all 7 crew on board. And you could imagine the consequences on the media if something like this, built to carry more than 100 people, would crash into the ocean. But continuing from where we left off, after clearing that dense cloud of pulverized blast-proof concrete, we immediately start to see the vehicle's telemetry updates come in. The rocket continues to rise, slowly at first, but then gets faster and faster as more and more fuel is getting burned and it gets lighter. Some of the heat shield tiles fall off the engines, which leads to some failures later. Did you catch that? That was the vehicle's hydraulic power unit, or HPU. It controls everything moving on the rocket, from engine valves to grid fins and pitch. So seeing part of it explode is not a good sign. Many disposable rockets use pyrotechnics, which are tiny explosives to separate them. But since Starship is supposed to be reusable, fully and rapidly reusable, it uses these small motors, again powered by the hydraulic power unit, which control clips, kind of like the little servo motors on remote-controlled vehicles. So after the explosion, the rocket continues to accelerate, going faster and faster and faster. This is where it reaches its max Q point, which is the point of maximum aerodynamic pressure, squeezing down on the rocket, almost destroying it. But the stainless steel structure manages to maintain it, and that is a true feat of engineering for the first flight of a rocket. But celebrations were short-lived. One of the first easily visible failure points is when this vapor trail starts to form at the back of the rocket. This is extremely valuable evidence because we can see the rocket's trajectory. This shows that the rocket is sluggish and trying to reach its target altitude without success, as it's not at a 180-degree angle with its exhaust trail. This is the failure point where stage separation is supposed to occur, but as you can see from the footage, it hasn't. Now the rocket quickly begins to lose its velocity as its engines throttle down in preparation for stage separation. The 122-meter tall stainless steel beast starts flipping around in every direction, still gaining altitude, but slowing down more and more. Now, since the rocket is no longer recoverable, the ground crew immediately set off the flight termination system, which is a little bomb strapped to the side of the rocket to completely destroy it in the event of a failure. The rocket continues to lose altitude until the flight termination system, eager to finish off its job, finally completed its sole objective in a spectacular explosion of stainless steel, methane, and liquid oxygen. At first, this launch may look like it went terribly, but it actually proved to be an extremely big success. Recovering data from all sorts of mission aspects, clearing the tower was just icing on the cake. This will help save similar rockets from a similar fate. I really hope you enjoyed this Head for Science video. Please remember to like and subscribe, and I'll see you in the next one.